Okay, so imagine this. You have a house. Okay. There's a ladder leaning up against the house. What shape have I just made? What kind? Okay, right triangle, because the house, okay, if your builder was a quality builder, your house is perpendicular to the ground. Okay. I did not build my house, but my house is very well built. Oh, that house? Yeah, the graph paper helped me a little bit. Okay. Here's the wording of the problem. A 5-meter ladder leans against the wall. Five meters tall. The bottom of the ladder is 1.5 meters from the wall at time t equals 0. So, okay, time is a factor because it's a rate. And slides away from the wall at a rate of 0.8 meters per second. Okay, so this is now traveling 0.8 meters per second. So somebody's going to get hurt, right? Find the velocity of the top of the ladder at t equals 1 second. Okay, that's our information. No, that's the screwy thing about these. They don't always work out that way. Okay. This is, so what you're going to find out is as the ladder falls, it actually accelerates, right? Because of gravity. So it's not a smooth, linear change. Okay, step 1 is to find the size of our triangle. No. Just, okay, we know this is 5 meters. Is that going to change? Okay. How far away from the wall is this at 1 second? No. At t equals 1. It starts at 1.5 plus 1 second.
0.7.
2.3 meters.
Sliding away.
It starts at 1.5. 1 more second is 0.8 more. You have to add them together. Okay, what is the value of the height? Of how high up the house is the ladder? Yep, we have a Pythagorean theorem problem.
Oh, so you're supposed to find the height at 1 second? Or the time it gives you have to find the height of...
We're going to find the velocity.
Oh,
But first we have to know the height.
okay.
Okay?
And we use that at a specific time it gives us?
Right.
Okay.
4.4.
Okay, does anybody disagree with what we just did?
So you got H to B. What is that?
4.44 meters. That's what Josh said, so I wrote it
Yeah,
down.
'cause it was 4.4395.
So I get,
Okay,
so the velocity difference for the top and bottom.
yes. You're gonna see.
It starts at that, 5 meters away from the bottom, and it has to travel up to, what is it, 3.5 meters, 4 times.
Something
The
like
top
that.
has to travel a bit different. And the top, like a little bit longer.
Then do you calculate it?
Depends on how high it is and the velocity. Let's figure it out. Okay,
Trying to say, what is H? 4.44.
that's a Pythagorean theorem, right?
Oh, now.
Wait, homework is a bunch of. So are we just taking it?
We're going to. Okay, here's one thing you have to know. Okay, is the value of x changing?
Yeah.
Is the value of y changing? Is the value of z changing?
Yes.
No.
Oh,
No,
No, what's
the
Y?
value of z is not changing. So we're gonna plug 5 in right now.
what isn't Z time?
No, he is,
It's the hypotenuse.
Oh, then what is changing? X and Y are changing?
Yes, the distances are moving, right? They're changing.
Oh, that makes sense.
Okay, just follow me. If there's something not changing, you can just plug it right in at first, because when you take the derivative, it becomes 0. Okay, so what is the derivative with respect to
X.
time?
So,
There's no t value in this equation, right? So every single derivative we take is going to have a dx dt or a dy dt. Okay, so
These are some solid notes.
okay, 2x, right? dx dt Okay.
We're finding it in respect to Y.
plus 2y dy dt equals 0.
Oh, I thought, oh.
Derivative of a constant is 0 if it's alone.
Okay.
All right, so the reason we differentiate with respect to time is because rates, velocities, right? Miles per hour, they have a time component to them. Now we plug it in, plug it in.
wait, what do we plug in?
What's our value for x?
Initially,
Oh.
No,
right
at t equals 1. And what's our velocity, dx dt, for the x-axis? 0.8. So that is x velocity, x position. What's the y value? Do we know the velocity? That's actually what the question is asking. Find the velocity of the top of the ladder. That's this one. dy dt.
Where did 0.8 come from?
It is the
The velocity of the x-axis.
Oh,
velocity that the x-axis is changing. So we put that in for dx dt.
oh.
Now solve that equation.
hold on a second. What is X equals the distance from the house at the bottom of the ladder?
Wait,
Okay, focus, focus. Solve the equation.
Okay, solve and you get.
46? What'd you, how about 4.6? Give me a decimal to 3 spots. Tanner?
Things to conceptually understand.
I did the 2 times.
Take a calculator.
I did the
Figure
2
it out.
times. 2.3 times 0.8, that's 3.68.
Okay, divided by,
By 2 times 4.44.
Yeah.
And I got 1.414.
okay, I agree with you.
46 over 100.
Okay, I get that. I agree.
So the top of the ladder is traveling at 0.414 meters per second. Okay.
And we were supposed to find,
Are we stuck?
we're supposed to find the rate of change after 1 second of the ladder
At
at
the top of the ladder,
the top of the ladder.
which we did.
I did 2 times 2.3 times 0.8 divided by 2 times 4.44. Wouldn't that work?
Yeah.
And then I got negative 8.1.
Oh, it's negative. It's negative.
But how did you get that? I got a 20 answer for that.
Okay.
Really, did you specify when you were dividing that as parentheses 2 by 4.44?
Yes, I used.
So what would change if we were finding the rate
It's
of
0.414.
that wouldn't change if
That
we
you're
were
dividing
finding
by
the
2
rate
to
of
make
change
my
from
bottom
bottom
of
of
the
the ladder.
watch. So then you take this
And the ladder is,
to parentheses.
it's like equilibrium, the area within that triangle should always be the same.
Area.
Yeah,
The
same.
area is two-dimensional.
So then the top of the ladder and the bottom of the ladder moving the same speed. Not,
Okay, never mind.
Order of operations error.
Try it at time equals 2. And you'll see.
never mind. I figured it out.
No, you didn't.
Because what you when you move
This one has
the
actually.
2 times power creating 0.8 over, when you minus it off, then it's kind of like this, and then you divide that like 2 times 4.44, and it still is that.
Okay, do you want to fill a rectangular tank or track a rocket?
Rectangular tank.
What do you think? Tracking a rocket or filling a rectangular tank with water?
Well, rectangular tank is more linear, and rocket is
It's pretty easy. Let's do the rocket one. It's pretty easy. Okay, let's just hope this rocket doesn't blow up like the one did last week.
Yeah.
So you have a rocket blasting off.
I actually kind of wanted to go out there. I don't have to do it now.
Oh, shut up. And you're watching it go up, up, up.
Start going on the rocket because I'm hitting that.
Yay, it's cool. Okay.
Oh, there it is. Hello, rocket. 26.
We are 6 kilometers from the launch pad.
Wait, are you watching it from the bottom of your feet or your eyes?
We're not going to get that specific because we're in kilometers.
We're laying on the ground, that's the other.
Okay, the angle theta, pi over 3.
That's filming.
But that's still like in I'm just trying to think of like
So the angle is pi over 3. The rate of change of the angle is 0.9 radians per minute.
You just pulled it out and over. Was that given?
Yeah, these are the givens.
Oh.
Yeah.
So let's give it, okay.
The question is, what is the rocket's velocity at that moment? Are those Sour Patch Kids?
Yeah. You want one?
Yeah.
You going right now?
Oh! Okay. Thanks. All right, let's move on here. Woo! We like those Sour Patch Kids. What function are we going to use? We have an angle, opposite, and adjacent. Okay. So number one was our picture, right? How high in the air is the rocket? That's challenge number one.
Where did it, oh, duh, oh, okay.
Or do we even need the height of the rocket?
1 6, okay.
It's 3.
Y is 3?
Yeah.
Okay, I don't think we need it, but it works. So we have tan theta. Okay, again, theta is changing, so it has to be a variable. I'm going to erase that for now. No more trusting Ben Coleman. Okay, the height is changing, but the distance from the launch pad is not, so we can insert a 6 in here.
10.39.
Okay.
Why did it change it?
Because it's opposite over adjacent.
Oh, I see.
Right? Toa?
Yeah, that length and you're given the angle.
What is the derivative of tangent? Okay, so we have secant squared theta d theta dt. Because with respect to time, it's velocity here. Equals, what's the derivative of y over 6?
One half.
No. What's the derivative of y? 1 6 dy dt. Okay. Don't make it harder than it is. Okay, don't make it too hard on yourselves. Like hitting your head against a wall and trying to make a hole.
To the power of 2
Do we have, okay, what's theta? Okay, pi over 3. What's d theta dt? Allie, W. What's d theta dt? How fast is the angle changing? Yeah.
Where did you get that?
It's a given. It's a given. So is the angle measure. Yes. The only thing that's not given is the rocket velocity. That's what we're going to leave as dy dt.
Divided by 1/6, what is that?
Can you solve for dy dt?
Yeah, solve for dy dt.
Do? Okay. Hey, whatever.
Okay, there's your, what's secant squared of pi over 3? Four?
6 is, I multiplied by 6 to move the 1/6 out.
Okay.
So remember secant is 1 over cosine. I believe that is 5.3 or 5.4.
Oh.
Cosine of power 3 is 1/2. Treg students just learned that today.
Wait, what did they do?
That gives us,
Oh, that's awesome. I missed that one day at school and I struggled with that subject all year. It was like 3.5.
yeah, I had 9 people absent today in that class.
Oh, gosh.
Life
You
is
missed
gonna
that,
suck.
and it messes up the whole class.
But they have videos to watch. You didn't. 21.6 kilometers per minute. That's pretty fast. Times 60. It's like 1,200 kilometers an hour. 1,300 almost. How many miles per hour is that?
A lot.
How many kilometers are there in a mile? 1.6? Wrong. You guys aren't cross-country athletes, are you? It's 1.61.
I know that 3 kilometers is like 5 miles.
Anyways, it's really fast. Okay, those are the basics.
No, that's the other one.
We'll go over a couple more on Tuesday. A couple of harder problems. But I want to get you started and see what you can do with these. No. Do it.
And then you said the other way around, it's like 5 miles, 3 miles.
That's a lot different. Oh, no.
Related rates are the law. Or unless it's really helping the airports. Everything that,
That's due Wednesday.
everything. Are we working on Tuesday?
I'm going to show you 3 more examples on Tuesday that are harder. Because these do get harder, and the one on the AP test will be harder. And then we'll, your test is next Thursday. So if you need to start studying this weekend, you do that. It is an AP style test.
Thanks for asking everybody to do their tests on Thursday. Now we have to do it on Thursday and Saturday. Great, now, thanks a lot.
What?
I don't even ask every teacher to do tests on
Not every
Thursday.
teacher.
Oh,
She asked you.
I can ask every teacher.
I don't remember you asking me.